advanced type of problems to be discussed. As long as mains is concerned, yes, everything is finished. NEET is concerned, everything is finished, and we have gone beyond the limit also, right? Stoichiometry, gaseous state, and atomic structure. These topics we have completed. Now we are going to the fourth chapter of 11th syllabus. This chapter is both purely conceptual and there are some slight tough type of problems where not tough because of part of the universe. One substance to other substance, maybe chemical substance, maybe physical substance, maybe chemical reaction, maybe chemical physical process. So in chemical reactions or in physical processes, if there is a flow of heat energy, that flow of heat energy, how much amount of heat energy is going to flow, and all that, that is to be discussed in the name of chemical thermodynamics. This is the apparent clear understanding by the name thermodynamics, but there is one inherent concept available which the name will not reflect. That is, thermodynamics really and actually discuss about possibility of chemical reaction, possibility of physical process, feasibility. The word which we use is feasibility. What is the meaning of feasibility? Possibility. Possibility of chemical reaction under given set of condition. That means this chapter will uh, inform us, gives us knowledge about whether this reaction is possible or not possible under given set of conditions. H2 plus O2 gives you H2O. Possible or not? H2 plus Cl2 gives you 2HCl. Is it possible or not? If I ask you to write down the equations, you may write hundreds of equations on the board or paper, and you can even balance those equations also. But main question comes in this case, sir, whether this reaction is possible or not, right? So to answer this question, whether the given reaction, whether I have written some reaction on the board, sir, I have written some reaction on the paper, whether it is chemically, practically possible or not. To answer that, we have to read the chapter known as chemical thermodynamics. Here we learn some information which gives you idea, okay, now it is possible, okay, now it is not possible, something like this, right? The word possible or feasible does not mean to say every time possible. The word not possible does not mean to say every time not possible. Feasibility or possibility is a conditional word. That means this chapter will give you information to understand, okay, sir, this reaction is possible under this set of condition. What is the meaning of condition? Temperature, pressure, something like this, right? So at this condition, okay, this reaction is possible. At this condition, this reaction is not possible. For example, go back to your uh, organic chemistry 10th class, H2 methane plus chlorine. What your teacher told you, methane plus chlorine is chlorination of hydrocarbon is photochemical reaction. What she says, she said that beta the reaction is possible in for sunlight or not possible in case of dark. Yes, how it is decided there, it is not possible to understand because of your lower maturity. Now you are mature enough to understand, yes sir, why that reaction was not possible in dark, why that reaction was possible in presence of sunlight. To answer that, we have to check up certain conditions that we'll discuss in this chapter. So what is our objective? Our objective to study flow of heat energy in chemical reactions, flow of heat energy in physical processes. Point number one. Point number two, no sir, we are also trying to enjoy the feasibility, possibility of chemical reaction or physical process under which conditions. That is the main objective of thermodynamics. It's a very, very big chapter. Therefore, I'll classify this chapter into three sections. Thermodynamics part 1, where we discuss first law of thermodynamics. Thermodynamics part 2, where we discuss thermochemistry. It is a different chapter in some books, right? In some books, it is combined chapter. I'll take a separate section. And third is thermodynamics, second law and third law. That is called third part. So we discussed thermodynamics part 1, part 2, and part 3. Today we are starting part 1 point. Okay, come on, turn up your what we can say fresh page and then start with all sincere and dedicated positive attitude. During a chemical reaction or a physical process, chemical thermodynamics deals with A, flow of heat energy, B, feasibility under given set of conditions of temperature and pressure. It deals only with macroscopic properties but not microscopic. Now this is limitation. What is possible? A and B. What is not possible? Sir, in this chapter, what you are not going to understand. We don't talk about microscopic properties. Mass of electron, mass of proton. No, we don't discuss about all these things. What is mass of 1 mole of substance? 10 moles of substance. Quantitatively, bulk quantity we'll discuss here in this case, macroscopic property. We'll discuss energy of electron, atomic structure. No, we don't discuss here, sir. We discuss energy of system, chemical substance. 2 moles of carbon dioxide, what is the energy? That we'll discuss here. What is the energy of electron? What is the velocity of electron? All we have done. That is called, these are called microscopic properties. Now we don't discuss this one. We talk about energy of 1 mole of hydrogen gas, 1 mole of oxygen, something like that. So it deals only with respect to macroscopic properties. We never talk about microscopic properties. Next, we are saying possibility is discussed. Okay, fine. If suppose, for example, a chemical reaction is possible, then there will be a question in your mind. Okay, sir, I understood by learning complete chapter of thermodynamics. When you finish this chapter, you may say, yes, I know under what condition it is possible. Then one more question comes to your mind. Sir, if it is possible, whether this reaction is fast reaction or slow reaction. Thermodynamics never talks about this. Thermodynamics never says whether the reaction is having fastness or slowness. It never talks about rate of chemical reaction. You know the word rate. Change of rate is always discussed with respect to time parameter, right? Rate of change of position is called as velocity. Rate of change of velocity is called acceleration. Something like that. Here also what we say that we talk about possible hai, hoga, nahi hoga, full stop. Fast hoga, slow hoga. No, we are not going to discuss that part in thermodynamics. It never deals with the rate of chemical reaction. No, we don't discuss. Hoga, that's all. How much bad jana hai. After how much time it will take place? No, we are not discussing that one. It is possible, it is not possible, right? Okay. Once you understand what is to be done, what is not to be done in this chapter. Next. What is next, sir? Mole concept. We know something about mole concept from 10th class. Atomic structure. Okay, sir, we know from 8th class onwards. We have extended the discussion in our class, 11th class. Gaseous state. Sir, I know Mr. Boyle and Charles everything from 10th class, and we have extended to all this. But what about thermodynamics? No, sir, we don't know this one. For the first time in our life, we are listening the topic chemical thermodynamics. Therefore, since we are discussing this for the first time, we should try to learn nomenclature of thermodynamics. What are the terms which are used in thermodynamics? First, we have to learn that one. Okay, let us see. Nomenclature in chemical thermodynamics. Number 1, system and surrounding. Okay, what is the meaning of system and what is the meaning of surrounding? What is system? System is defined as that specific part of the universe which is under our observation. Listen carefully. System is that specific part of the universe which is under our observation. For example, if I am teaching to you on the screen in online system, what is my system? My system is the screen on which I am explaining you. But beside it, I am having CPU. Beside that, I am having UPS, and everything is available. They are not called my system. I am dealing with mouse, right? Mouse is not my system. System is only that screen of the computer which is I am using is not my system. What is my system? That portion of the screen on which I am writing, left hand side part you are writing, sir, that is the system, right? Arif's classes left hand side, center side, right? Three headings are given in watermark. No, sir, all of they are not your system. Even though you are having that on the screen, you are specific, very specific. Left hand side, you have written something black and red. Only that part is known as system. System is defined as specific portion of the universe which is under our observation. Is it clear? If you understand that system is a specific part of universe which is under our observation, remaining part of the universe, whole universe is called surrounding. उसको छोड़ के जो भी आएगा वो surrounding होगा, right? System is specific portion of the universe which is under our observation. Remaining whole thing is known as surrounding. चलिए, if suppose you take system and surrounding, combine them, क्या बनेगा? Universe बनेगा. What is universe? In thermodynamics, universe means a setup of two things. One is known as a system, one is known as surrounding. Both of them put together is known as universe. What is universe? Universe is system plus surrounding according to thermodynamics language. Okay. Now, system and surrounding. When you are saying that there is a system and there is surrounding, sir, ये दोनों एक है या अलग है? Both of them are different. ओके ठीक है, अगर दोनों डिफरेंट है तो दोनों के बीच में कोई ऐसी चीज है जो इनको समझा सकती है. यस, रिमेंबर दैट सिस्टम एंड सराउंडिंग आर ऑलवेज सेपरेटेड बाय ए बाउंड्री. सिस्टम and surrounding is separated by a boundary. Okay, how it looks like? Yes, this is called system. The yellowish portion is supposed to be the system part, and the red line available here in this case is not system. Red line is not system. Red line is boundary, and boundary is surrounding. Are you able to understand the beauty? This is surrounding. ये सब surrounding है. जहाँ जहाँ mouse घूम रहा है इसका marker, right? That it all is supposed to be the surrounding. No, no, sir. Red line is also surrounding. That means what is boundary? Boundary is also a part and parcel of surrounding. Is it clear? No, sir, not yet clear. One more example. Okay. I am discussing variation of something in terms of a gas. I am studying this gas, say for example, okay, I am heating the gas, or I am pushing the piston down to compress the gas. Something I am doing. What is this called? Piston. Piston is not in our observation, sir. I am applying pressure on the piston, but I am not observing what is going on the piston. I am observing what is going on the gas. Therefore, this gas is known as system. Piston, surrounding. The cylindrical vessel, surrounding. Are you able to understand? Yes. This specific portion of the universe which is under our observation is known as system. Remaining whole is known as surrounding. And system and surrounding are separated by a boundary. See here, this piston is called boundary. This wall of that system, cylindrical vessel, is called as boundary. Okay. Boundary is a part and parcel of surrounding. Next. Okay, sir, when you are saying boundary, how do you classify boundary? Boundary, what is a boundary? These are real or imaginary surfaces which separates system from its surrounding. Yes, here we have system, here we have surrounding. How do you separate them? I am drawing a line, right? This line is known as boundary. It is a surface which is separating system and surrounding. And if it is so, there are two types of boundaries which are separating system and surrounding. They are real boundaries and imaginary boundaries. Real boundaries which you can visualize. Imaginary boundary which we can understand but you cannot visualize, right? We can feel, right? Air is available surrounding to us. We can feel it, right? Show me the air, catch up the air. That is not suitable way. Real boundary. imaginary boundaries. Boundaries are of two types. We are having a real boundary as well as imaginary boundary. Now, once you are saying that we are having two types of boundaries, then naturally in your mind you may have a question, sir, I want to enjoy those boundaries. Come on. See here, we are having a experiment where what is my observation? My observation is to study variation of temperature of this liquid by supply of heat energy. I'm repeating that one. You should have that skill to explain the figure systematically because you are a scientist. Therefore, what we can say, sir, you are trying to study variation of temperature with respect to heating phenomena. You have all these arrangements. Come on. Are you observing thermometer? No, sir. Are you observing this beaker? No, sir. Are you observing mesh? No. Are you observing stand, burner? No, 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 nothing. All these are called as surroundings. What is a system? System is water, liquid available in the beaker is exclusively known as system. And the remaining whole beaker, thermometer and mesh, burner, stand, all they are called as surrounding. Come on. Now here, when this cursor is there in the mouse, remember this wall of the beaker is called boundary. Which type of boundary? Can you touch it? Yes, sir, I can touch it. That is called real boundary. Whereas if suppose you are saying here, sir, above this here we have gas, atmosphere. Here I am having liquid. So liquid and atmospheric gas, both of them are having a surface. This surface of liquid is also called boundary, but I cannot touch it to feel, sir, this is separating. This type of boundary is called as imaginary boundary. Whenever we talk about imaginary boundary, it is available in between liquid and gases, solid and gases. Wherever you are having gas, there is a possibility of imaginary boundary. If suppose, for example, you are having this glass vessel, these boundaries are called as real boundaries. Okay, sir, I understand types of boundaries. Once you understand the type of boundary, then you may have one more question in your mind. Sir, if suppose you are talking about type of boundary, real and imaginary, then can you further classify that? Let us go to classify. I can classify real boundaries. Imaginary boundary is only one type. How do you classify real boundary? Okay. Real boundary may be classified as a rigid boundary or it may be classified as flexible boundary. Rigid, take care of the word. Flexible, how do you proceed? Sir, see this one. I am having this boundary, right? This boundary is supposed to be a fixed rigid wall. I cannot expand it, I cannot compress it. Such type of boundary is known as rigid boundary. Whereas if you are having a piston, I can push the piston down, I can lift the piston up. Flexible boundary. This is called flexible boundary. And what is wall of the container? Wall of the container is rigid boundary. Are you able to understand? These walls of the container, rigid boundary. Piston is supposed to be flexible boundary. Both are real boundaries. This is real and this is supposed to be rigid, real. This is known as real but flexible. For example, balloon. If you are talking about the balloon, then inside the balloon we are having gas. Outside the balloon we are having atmosphere, and the leather which is used to prepare the balloon, that is supposed to be boundary, and you can expand it, you can compress it. That is called flexible boundary. Okay, come on, note it down. Go ahead. Piston. Anas, what is piston? ओल्ड सिटी की लैंग्वेज में बोलते हैं ढक्कन, ऊपर एक ढक्कन रख दे के उसको आप ढक्कन को दबा रहे हैं, उसको बोलते हैं पिस्टन. कॉमन वर्ड है बेटा. लिड जिसको बोलते हैं आप. Go ahead, write down. What is the problem, Ansari? What is the doubt? Tell me, beta. What is your doubt? I can tell you, but what can you explain once again? That word is not in my dictionary. I will never explain anything second time. If you have doubt, tell me, sir. ये समझ में नहीं आया, वो समझ में नहीं, कोई पॉइंट पूछिए, मैं समझा सकता हूँ. एक्सप्लेन इमेजिनरी एंड रियल बाउंड्रीज. देखो वहां फिगर देख के जरा सोचो कैसा बोल रहा हूँ. रियल किसको बोलते हैं? और आपके नहीं, no, कोई बात नहीं बेटा, कोई बात नहीं, डिस्कनेक्ट हो गया आप, कोई बात नहीं. जरा देखो वहां पे रियल बाउंड्री क्या है, इमेजिनरी बाउंड्री क्या है, इमेजिनेशन, रियलिटी किसको कहते हैं, जरा सोचो. ठीक है. यस, यू शुड ड्रॉ एवरीथिंग. सिस्टमैटिकली ड्रॉ करो. एक पेंसिल रखो हाथ में, नोटबुक होना चाहिए. Thermodynamics is the first time you are learning in your life, therefore you can proceed in that way, right? Chemical thermodynamics. Anas is saying that CTD stand for chemical thermodynamics. You are genius, beta. Very good. Correct. Real boundary. Ansari, real boundary. You can feel that one. Glass wall is real boundary. इमेजिनरी बाउंड्री वहां कुछ भी नहीं है, लेकिन आपको समझ में आ रहा है कि यहाँ पानी खत्म हो गया, यहाँ से गैस शुरू हो रही है, दोनों के बीच में कुछ नहीं है. दैट इज कॉल्ड एज इमेजिनरी. एवरीथिंग यू हैव टू राइट, एवरीथिंग यू हैव टू ड्रॉ, राइट. आपके ड्राइंग के लिए ही क्लियर कट पूरा लिया हूं मैं. उसके लिए हम सब सिस्टमैटिकली रात में मेहनत करके सेटअप करके रखते हैं. अब उसमें मैं ड्रा करूं क्या, नहीं करूं क्या, ड्रा नहीं करेंगे तो नुकसान उठाएंगे. एक पेंसिल रखिए, साथ में कलर रखिए, 2 पेन्स रखिए, आराम से इत्मीनान से लिखो, सलीके से लिखो. नोट्स नोट्स ऐसे रहना कि देखे तो पढ़ना, दिल बोलना नोट्स. अच्छा चलिए 1-2 घंटे पढ़ लेंगे. कमान कमान, हरी अप हरी अप. जज़ाकल्लाह खैर. वही, थैंक यू बेटा. Ejaz. No, beta, this is completely independent. There is no connection with other. Therefore, I said start with nomenclature and all. इसका अपना own existence है, इसकी अपनी अलग पहचान है. There is no connection. Atomic structure, gaseous state, no connection. सिर्फ एक मोल कॉन्सेप्ट ऐसी चीज है स्टाइकियोमेट्री जो throughout all 2 years chapters are connected. This is independent topic. Is it over? Okay, go ahead. No problem. Write down systematically. Mohammad Ansari, is it now clear? Real boundary and imaginary boundary. Fine. In this chapter, there is one beauty that everything is very much connected. In every chapter, every topic is interlinked, but here it is, the linkage is very strong. So if you leave or if you are unable to understand any portion in the basics, then throughout the chapter, unnecessarily you have to cry. Therefore, concentrate properly. Doubt है तो specific पूछ लीजिए कि सर ये क्या है. Instead of asking total, explain everything, you can ask any typical, yes sir, this point I am unable to understand. Is it over? Okay. ठीक है, लिखिए. Write down. Go ahead. Done. Muhammad Hussain, done. Shoaib, Laik Ahmad. Once it's over, tell me. Okay, nice. Laik, is it over? Fine, come on. Now, I'm just going back. What we have learned? System, surrounding. Okay. Now, once we have discussed system and surrounding, then, sir, there is a boundary. Once you understand boundary, then you said what type of boundary? Real boundary and imaginary boundary. Then in real boundary, again, we have rigid boundary, flexible boundary. The word rigid boundary and flexible boundary is one way of classification. ठीक है? There is one more way of classification to the real boundary, right? यहाँ पे क्या मतलब है rigid boundary? Volume remains constant. Try to understand the meaning. What is the meaning of rigid boundary? Volume remains constant. What is the meaning of flexible boundary? Volume is variable. ठीक है? अच्छा, और थोड़ा सा अंदर चलिए. Sir, rigid boundary means volume is constant. Okay. If volume is constant, pressure is variable. PV is equal to nRT. Volume is constant, pressure is variable. यहाँ क्या बोल रहे हैं आप flexible boundary में? Volume is variable, pressure must be constant. That is the classification based upon PV, pressure volume discussion. Once I explain like this, sir, I am classifying real boundary in terms of rigid and flexible depending upon which is constant, which is variable in terms of pressure and volume. Then naturally your mind will ask you, what about temperature? If you want to talk about temperature, then we have one more way of classification. What is that classification? Is it possible to have flow of heat energy? Is it not possible to have flow of energy? That means this boundary can allow the energy, heat energy, to go in, come out, or this is not allowing energy to go in and come out. If it is so, there is one more way of classification. Come to second slide. What is that classification? This classification is a adiabatic boundary, diathermic boundary. Adiabatic boundary means no loss of heat, no gain of heat. It is a boundary where you cannot have anything released, any heat energy released or absorbed. Insulation, thermos flask, right? In case of thermos flask, what is that boundary? Sir, the tea is available in hot condition, neither its temperature is decreasing, nor we are able to further increase temperature. That is called insulation. That type of boundary is called adiabatic boundary, adiabatic wall. Diathermic wall, it is a wall which allows heat energy to go in and out. For example, glass beaker, I can send energy inside, I can remove energy outside also. So glass wall is diathermic. No, sir. Why don't you say like this? Diathermic wall means, diathermic boundary means conducting vessel. Yes, heat conductor. The boundary must be heat conductor. And if the boundary is heat insulator, it should be called adiabatic boundary. Is it clear? If it is so, let us enjoy the game. Yes, sir. Hot and cold, we are having heat not going inside, it's going and getting out. This is the boundary which is called adiabatic. Passage of heat is not allowed, no permission. Here, no sir, it is possible to go from hot to cold because heat energy always flow from a body at high temperature to a body at cold temperature. Therefore, this is possible. I can, if I am saying that in case of cold, if I take reference as cold, heat energy is coming inside. If I talk about hot body, heat energy is going outside. This arrow is of two ways, right? Are you able to understand the meaning? With respect to cold, I am saying energy is received. With respect to hot, I am saying energy is released. Heat energy can be sent out, can be taken in. If it is so, it is called diathermic wall in technical language. In common language, sir, heat conductor, right? Passage of heat energy is permitted here. This is called adiabatic boundary, diathermic boundary. Classification of boundary in terms of rigid and flexible is based upon pressure volume variation, whereas classification of a boundary in terms of adiabatic and diathermic depends upon the flow of heat energy. Right? Once you understand the boundaries, then come back again. Sir, you said system. What is system? A specific portion of the universe which is under our observation. Then the question is, sir, suppose for example, if you're having system, definitely there must be surrounding. If there is system and surrounding, there must be boundary. If you are having boundary, maybe rigid boundary, maybe flexible boundary, maybe adiabatic, maybe diathermic, but there will be something going on in between system and surrounding through the boundary. Are you able to understand? I'm repeating the sentence. There must be something going on in between system and surrounding through the boundary. Therefore, if suppose for example you are saying something is going on, depending upon that something going on, shall I classify system? Yes, sir. I should know that what is going on in between system and surrounding through the boundary. For example, roll number 1 says, sir, I can exchange matter. I can add matter. I can remove matter. No, sir. I can add heat energy. I can remove heat energy. No, sir. I cannot do anything like that. If suppose, for example, something is going on in between system and surrounding through the boundaries, on that basis, we'll classify the system into different categories. What is that? Types of system. Number 1, open system. What is the meaning of open system? Exchange of both matter and energy in between system and surrounding is possible. It is a system where I can add energy, I can remove energy. I can add matter, mass, I can remove. There is a beaker. Say for example, beaker, right? Glass beaker. Right, I am having certain amount of chemical substance. Can I add some more chemical substance? Yes, sir. It is open beaker. Can you remove? Yes, sir. I can do. I can add matter. I can remove matter. Acha. Glass. Can you heat it? Yes, sir. Energy is supplied. Can you remove heat energy from that? Yes, sir. It is possible. If suppose there is a system which can do both the jobs. What? exchange. Use the word exchange. Exchange of matter in between system and surrounding. Exchange of energy in between system and surrounding. Such type of systems are called open system. Example, heating of water in a beaker. Very good example, simple language to understand, and a very beautiful example. You, right? All animals are open systems. Human beings, right? Animals, everything. We are social animals and they are animals. Everyone, living systems, all living systems. Nature has created open system. For example, see that one. This is system, this is surrounding, right? If you are trying to call it as open, what is happening? Energy is going out, coming in. Matter is going out and coming in. Okay, sir. Let us try to enjoy another beautiful example. A conical flask, open conical flask. Open. I can add matter. See here, gases form is releasing out, matter is going out. And heat energy, sir, it is a glass. Therefore, mass can be exchanged, heat can be exchanged. If both exchanges are possible, open system. Reactants in an open beaker, example, all living systems, beautiful example. Now you are genius, you can say okay, okay, अब दो हैं, if both are possible, open system. चलिए, one is possible, one is not possible, closed system. Only exchange of energy but not matter, close. Pack up that, pack up the beaker, conical flask. Then you cannot have addition or subtraction of matter, but energy can go in and out if it is possible. It is called closed system. Yes, we are having system surrounding. It is said to be closed system if there is exchange of only energy. I cannot add it. That means I have taken same conical flask, I have kept piston over it. Once I push the piston, you cannot have exchange, removal of mass, addition of mass, not possible. See the cross. Heat energy, yes sir, it is a diathermic wall. This is known as diathermic wall, where you have exchange of system. Example, chemical reaction, closed conducting vessel, closed conducting vessel, conducting vessel. Glowing of bulb, energy can come outside, glowing of bulb, right? These are closed system. Chaliye, both are possible, one is possible, both are not possible, ऐसा भी हो सकता है. If suppose it is so, it is called isolated system, right? Isolated system means neither energy nor matter can be exchanged in between system and surrounding. No chance of any process, right? Alag thalag. If you are having this one, it is called isolated. For example, there is a system surrounding. What is that? It is closely packed and it is, see that brownish color. What is this? Insulation. Cotton लगा दीजिए पूरा completely और wooden pieces डाल के pack कर दीजिए. If it is so, though no chance of exchange of heat energy, no chance of exchange of matter. If system is like this, it is called isolated. इसका मतलब है, in case of isolated system, we cannot have any connection with the surrounding. No connection. There is a possibility of doing something high by, right? Here also it is possible to have anything, but here no relation is mixed with, available with surrounding. For example, hot water in a thermos flask, right? Then beautiful example is universe. The whole universe is one single isolated system. जो भी होना है यही होना है. It has no contact with its surrounding. There is no connection with the surrounding. In between system and surrounding, no relation is available. If it is so, it is called as isolated system. Therefore, there are three types of systems available. Surrounding we cannot classify because surrounding is not in our control. Our control is only with the system. Okay, sir. Once I understand system, then naturally a system should have property. Right? Ajaz is asking question, can there be only exchange of matter and no energy? No, it is not possible, right? You can do it at home, right? He is saying that exchange of matter, no energy. Yes, you can do it at home, but in thermodynamics, we don't have that classification. Are you able to understand? You can do it on. He is saying that I want to have exchange of matter. Open रखो इसको, यहाँ open रखिए, इंसुलेशन कीजिए, हो गया. लेकिन वो classification system define nahi kare. Thermodynamics will not accept this. What is the doubt, Anas? What is the doubt? Who is this boy? Anas Siddiqui. What is the doubt, beta? You are saying closed system, isolated system. क्या doubt क्या है बोलिए? What is the doubt? You are not able to understand. What is that you are not understanding? यहाँ देखो सब क्या क्या दिख रहा है, फिगर्स हैं, राइट, रिटन में भी है. क्या डाउट है बोलिए? क्या समझ में नहीं आया? यहाँ दोनों में पहले जरा दोनों आंखों से अच्छा देखो, फर्क क्या है, इसमें फर्क क्या है, इसके अंदर क्या चीज लगाया मैं एक्स्ट्रा, यहाँ क्या हो सकता है बोला मैं, क्या नहीं हो सकता है, यहाँ क्या क्या नहीं हो सकता है. Is it clear now? See that carefully, see that carefully. Come on. Once you understand system and surrounding, Nihal, beta, this is a typical one. You are asking something which is not suitable. Isolation can be temporary. How it is temporary, right? You are not concentrating. Please, थोड़ा maturity बढ़ाइए. देखो मैं क्या बोला आपको. Isolated system example is universe. You are asking, sir, isolated can be temporary. Universe temporary. मिलाओ दोनों को. मिला के देखो कि हम लोग जिंदा हैं. यूनिवर्स है टेम्पररी, इसका क्या मतलब हो? टेम्पररी कुछ भी नहीं है बेटा. थर्मास फ्लास्क है, इज इट टेम्पररी? नो, इट इज परमानेंट. थर्मास फ्लास्क, सपोज फॉर एग्जाम्पल, सी हॉट वाटर इन ए थर्मास फ्लास्क, इज इट टेम्पररी? नो, इट इज परमानेंट. इट इज परमानेंट. गॉट इट? हाँ, इसकी कोशिश करो. आपका टाइम वेस्ट हो रहा, मेरा नहीं हो रहा. आप थोड़ा कोशिश करो अच्छा देखने की. आई एम सेइंग कंसंट्रेट, एक एक चीज को गौर से देखिए. राइट, वो आपको एटीट्यूड बनाना है वैसा. यू हैव टू लर्न दैट वन इन आवर क्लासेस. यू हैव टू लर्न दैट वन. देयर इज अ गुड हैबिट. आएगा, आहिस्ता आहिस्ता आएगा, थोड़ा टाइम लगेगा. चलिए, वंस यू अंडरस्टैंड द सिस्टम, ठीक है सर, बात समझ में आ गई. सिस्टम क्या चीज है, सराउंडिंग क्या चीज है, बाउंड्री क्या चीज है, एंड हाउ मेनी टाइप्स ऑफ सिस्टम. अब क्वेश्चन क्या आएगा आपके माइंड में? यू हैव टू क्रिएट क्वेश्चंस. चलो ठीक है, सिस्टम तो पढ़ लिए, सिस्टम के अंदर जाना चाह रहे हैं आप. यू वांट टू लर्न समथिंग अबाउट सिस्टम. देयर मस्ट बी सम प्रॉपर्टीज. नेचुरली every system has a property. Sir, property, which property? Chemical property, physical property. Yes, everything has these two things. Today we learn one more name. No sir, thermodynamic property. Yes, thermodynamic property. Right, they are physical and chemical only, but we define a stylish type of word. We are defining here thermodynamic properties. What are thermodynamic properties? Maybe a physical property, maybe a chemical property, but what is the beauty or uniqueness of this property? Come on, let us try to classify. How to classify that one? Thermodynamic properties are classified into two different categories, right, depending upon who are you, how much are you. बात समझ में आई? Who are you? Quality. Who are you? Sir, I am IP student. Sir, I am NEET student. Sir, I am advanced student. Who are you? How many are you? 45, 25, 35. That is not, that is the way with which talk about quantity. Quality, quantity. These properties are classified as extensive and intensive, one way of classification. Paths and state function, another classification. ये अलग अलग चीजें हैं. What is extensive property, what is intensive property? That we have to learn today. Path and state function, that also we have to learn. They are two different ways of classification. जैसे यहाँ पे बोले आप, depending upon PV, we have one thing, flexible boundary, rigid boundary. Depending upon temperature, diathermic, adiabatic. वैसे ही quantity based upon discussion is extensive, intensive. And next one, first write this one, this much. If time is available, I'll go ahead. Anything to ask in this? Is it clear? Closed system and adiabatic, the isolated system, Anas, is it clear? And Nasser, it is a permanent. Every phenomena is permanent here. अब ये आपके कंट्रोल में है कि you can make it temporary, you can make it permanent. Both are possible, right? But concept is ये है, ये सिस्टम है. अब आप ये सिस्टम को टेम्पररी रखना चाह रहे हैं, ये परमानेंट, ये आपका अपना काम. You are going to do some process here. Okay? चलिए, write down that. Because the word temporary and permanent is in your control. As a scientist, you can make the process permanent. As a scientist, you can make the process temporary also. That is your job. थर्मोडायनेमिक प्रॉपर्टीज अभी नहीं पढ़ा है बेटा हमने, अभी तो स्टार्ट ही नहीं किया। आप ये लिख लो, उसके बाद में टाइम रहा तो पढ़ाता बोला मैं। रेहान, आई सेड दैट यू कंप्लीट दिस वन। थर्मोडायनेमिक प्रॉपर्टीज आई हैव नॉट स्टार्टेड, मैं तो सिर्फ नाम लिख के छोड़ा हूँ, अभी समझाया नहीं मैं आपको, राइट? वो समझाने के लिए टाइम लगेगा, वो टाइम होने से पहले आपकी क्लास खत्म हो जाएगी, इसलिए मैं उसको ब्रेक किया हूँ। आप ये लिख लीजिए, टुमारो वील डिस्कस थर्मोडायनेमिक प्रॉपर्टीज, ठीक है? चलिए, आई डोंट नो बेटा, चलिए ठीक है, पूछ लिए, मैं बोल लिया, राइट? आई एम थिंकिंग दैट दैट इज ए स्टूडेंट, देयरफॉर आई हैव गिवन आंसर। चलिए ठीक, कोई बात नहीं, लिखिए लिखिए। मोहम्मद रबा जैद, टाइम पास का है शायद। जूनियर एम्स 1, forget about that। चलो ठीक है। Is it over? Go ahead, go ahead. All right, one boy, Aves, he's saying written over. Okay, that means he's not writing and saying over. Aves लिखो बेटा, नोट्स लिखो, बाद में रोएंगे, बाद में रोना पड़ेगा कि नोट्स नहीं लिखे बोल के। लिखो, स्क्रीनशॉट लेने का स्टाइल मत रखो, लिखो लिखो। ओके, वेरी गुड, वेरी गुड। And don't write when I'm explaining, because this writing words which are there on the screen are not important. What I am saying, how I am explaining, that is important. So when I am explaining, listen calm and quiet. Then I am giving you time to write down. We have plenty of time to complete the syllabus. Completion is not necessary, understanding is necessary. Any doubt to ask? Those who have written, just have a look. Just have a look. Today, what we have done, just have a look, and then if it is possible, ask. Thank you. Moise, okay, nice. NCRT may not be suitable to you for thermodynamics chapter, right? Physical chemistry by O.P. Tandon, physical chemistry by Prabhat Kumar. Any book you can enjoy after referring notes. Just go through once from any book. Over. Sir, can we refer MS material? No problem. Go ahead. Go ahead. No problem. You can go ahead with material also. If you have any new thing in any book, KG to PG for thermodynamics, any physical chemistry topic, you can ask. If you are having, suppose sir, I am referring some other book, as you said, MS material or ओपी टंडन और बहादुर और प्रभात कुमार। इफ यू थिंक सर यहाँ तक जो आप पढ़ा है उसमें से कुछ नई चीज आपको मिल रही है, इफ यू आर एबल टू अंडरस्टैंड, बी हैप्पी। If you're not able to understand, ask that in the next class. Okay. आरसी मुखर्जी, अवेश भाई, आरसी मुखर्जी को हाथ लगाना हराम है। क्या है? हराम है। आरसी मुखर्जी इज नॉट ए टेक्स्ट बुक बेटा, वो न्यूमेरिकल बुक है, वो न्यूमेरिकल बुक है, राइट। आरसी मुखर्जी का नाम नहीं लेना है। जो लोग, सॉरी टू से, जो टीचर्स आरसी मुखर्जी बोलते हैं, पर्टिकुलरली नॉर्थ में चलता है ये सब, दैट इज नॉट सूटेबल बुक बेटा फॉर यू, राइट। अवस्थी कर लिए तो आप बहुत बड़ा काम कर लिए, बहुत अच्छा है, उतना काफी है। आरसी मुखर्जी में थ्योरी कुछ नहीं मिलेगी आपको, न्यूमेरिकल बुक है, लेकिन वो अब आउटडेटेड है, अपने काम की नहीं है, ठीक है, राइट। वेरी गुड। नाउ we'll stop it here. The discussion is what are thermodynamic properties. My seniors and me, I bought it. Okay, no problem. आप उसको रखें तो रोज सुबह में उठ के देखिए, राइट। किताब का कलर अच्छा है, देखिए, रखते जाइए फिर, क्योंकि वो सीनियर को मालूम नहीं होगा, जो आपको मशवरा दिया उसको बेचारे को नहीं मालूम होगा कि आरसी मुखर्जी क्या है। कभी अकेले में उससे पूछ लीजिए, भाई जरा सीक्रेट बात बोलना, तू पढ़ा के कभी जिंदगी में आरसी मुखर्जी बोलो, अब खुल के बोलेगा ओके नहीं भाई मैं लगा के रखा था, रोज सुबह में 2 अगरबत्ती जला के गोल घुमा के आरसी मुखर्जी बोलते क्या रख देते, ऐसे ही करते बच्चे, क्योंकि वो लेवल तक जाना आपके लिए सूटेबल नहीं है, क्योंकि आईआईटी का लेवल नीचे आया है, ठीक है बेटा। चलिए, टीचर की बात पे ध्यान दिया करो। सीनियर्स ओवर एक्टिंग करते हैं आपके सामने, क्योंकि आपको इंप्रेस करना रहता है उनको। थैंक यू, बाय, अस्सलाम वालेकुम। अल्लाह।